Hi, everyone. My name is Huey Han. I'm a product manager from Amazon S3. And here is my presenter, Dev Kumar, which is also from the S3 product team. And today we're here to talk to you about understanding why Amazon S3 is the best place to build your data lake. So before we get started, just a quick rundown of what we're going to cover today. First, we're going to talk about a brief history of what led to the data lake architecture today. Then we're going to talk about how AWS customers are using data lakes today. And after that, we're going to talk about some specific recommendations about building a data lake on Amazon S3. And specifically, we're going to talk about performance and then cost. So first, let's talk about a brief history of data lakes and what led to the data lake architecture today. So it all began in the early 90s, where many companies began to realize the value of data, where data can be transformed into insights, and these insights then drive better decisions making, and these better decisions turn into competitive advantage in the marketplace. So because of this, more and more companies began to leverage data, and a technical stack emerged. Typically, what the stack is analytics were done on an ad hoc basis against production databases. And these production databases are typically transactional relational database. And this approach and this stack worked well for a while. But then what happened is data continued to explode as companies realized the value of data and they began to collect more. And then within companies, personas using the data began to explode as well as people within organization began to realize the value of data. And data-centric companies began to grow faster because of their distinct advantage in the marketplace. So as data continued to grow and scale, this led to many issues on the technical analytics stack. And specifically, analytics against production databases can overwhelm the databases, causing performance and, more importantly, data integrity issues. So in the early 2000s, a new architecture began to emerge to address the problem of the previous generations. And this is where the idea of ETL, or extract, transform, load, came to be. And the idea is that rather than querying against the production databases, why don't we do analytics separately from the transactional database and load the data into a secondary data store that's specifically designed for analytic use cases. And this is where ETL is born, where raw data from transactional store is extracted, transformed into more analytics-driven, analytic-friendly table, and load it into the second data store. And along with this idea of ETL, many innovations began to emerge where the concept of OLAP, or online analytic processing, appears, along with a lot of techniques such as multi-dimensional models, analytic queries, real-time pivot table, et cetera, et cetera. And this tech stack and architecture worked well for a while. But then the same problem began to appear again, where data continued to explode as companies realized the value of data, began to collect more. Persona using the data began to explode as people realize the value of data, and data-centric companies keep growing faster. And this again brings a lot of problems to this new stack. Specifically, the second analytics data store has limited scaling capability because typically running on a single mainframe. And as the data grows and scales, this mainframe began to get overwhelmed again. So this is where Hadoop enter into the pictures. In the late 2000s and in the late 2000s, early 2010s, Hadoop offers a drastically different way to scale. So instead of scaling using more performing computer, what we now refer to as vertical scaling, Hadoop allows you to scale horizontally by adding more parallel computing power. And moreover, these computers can be commodity hardware, cheap to procure, and it doesn't have to be the expensive mainframe. So this new architecture brings a lot of new scaling capabilities to the big data problem. And on top of it, a really robust Hadoop open source ecosystem emerged, where you have a lot of different software frameworks like MapReduce, HDFS, Hive, Pig, HBase, et cetera, that really allow you to plug and play and customize your data lake stack depending on your use case. And this infrastructure and this tech stack worked really well for a while. But then the same problem again began to appear, where data continued to scale, and the same problem with scaling and scaling data, scaling persona began to emerge again. So for HDFS, one, it's really expensive to store data. So HDFS typically run on block storage, and block storage can get really expensive. And if you run it on-prem, you need to provision the storage ahead of time so that you don't run out of space. But getting to the right utilization ratio is tricky. You want to make sure that you're not leaving money on the table and over provisioning. At the same time, you don't want to under provision and constantly run into the risk of running out of capacity. And on top of these issues, HDFS also has a scaling limit of around 5,000 nodes and 20 petabytes of data. And as data continue to scale, a lot of the data-driven companies begin to hit the scaling limit. And last but not least, for HDFS, you need to scale compute together with storage. And compute is also really expensive, which means your Hadoop cluster becomes exponentially more expensive as the amount of data scales. So we see the same story of scaling data that brings a lot of problem again and again. And what do we really need here? What we really need is a centralized repository that really allows you to store all your data, whether structured or unstructured, at any scale, durably, and at low cost. But building this kind of solution is really hard in-house, because on one hand, your data continues to scale, where the amount of data that need to be stored, processed, and analyzed grow at an exponential rate. And on the other hand, your businesses have a range of hard requirements on your data, such as the data quality needs to be high, in the performance for analytics needs to be good, the cost to be low, the durability needs to be high, et cetera, et cetera. And these requirements cannot be sacrificed just to accommodate the exponential growth of data. So this is where the cloud and S3 come into pictures, where S3 was fundamentally designed to be highly scalable solutions able to accommodate any data, whether it's structured, unstructured data, at any scale, whether it's 100 terabytes or hundreds of petabytes, very durably and secure and low cost. So what this means is that S3 can satisfy your business requirement around scale, cost, security, durability, while accommodate any sort of growth of your data. And all of these benefits come with minimal operational effort on your end. So all this means is that when building a data lake, there's really no better place to start than S3. And to give you an idea of S3's scale today, Amazon S3 hosts more than 200 trillion objects and average over 100 million requests per second. And on top of the bread and butter storage of high performance and high scalability, S3 also offers unmatched fine-grained security controls, compliance and auditing capabilities, and lifecycle management features that all of them together make it the clear choice for customers looking to store objects on the cloud. Today, there are over 200,000 data lakes on AWS, and we have companies like BMW, Vanguard, GE Healthcare, Slack, and many more are adopting data lake as their single source of truth on S3 to help them drive decisions and new experiences. So harnessing data to reinvent your businesses, well, challenging is really imperative to staying relevant now and in the future. And it's really survival of the most informed. And those that can put their data to work to make better, more informed decisions, respond faster to the unexpected, and uncover new opportunities will thrive. And to do this, you need to build a data-driven organizations. And there are a couple dimensions to this kind of culture. First is make better and faster decisions with data. The main challenge that are holding organizations back from making better and faster decisions with data are typically due to data being in disconnected storage system, poor data quality, and lack of skills to use data effectively. An organization with the highest level of data maturity empowers employees, regardless of job function or business unit, to analyze and use the data to make decisions. The second dimension is improving customer experience and loyalty. So organizations are looking for ways to effectively use data and analytics to understand customer better and improve customer experience. From online experiences to contact center, organization can harness the power of data to create more value for the customers and address unmet needs proactively. And data can also help organizations create new businesses or monetization opportunities and build hyper-personalized products and services based on your customers' needs. And the third is handle customer data with care and integrity. So customers care about how their data is being used and the risk versus rewards of sharing data with businesses. And customer data contains a wealth of information to improve your business offering, but the sensitive data contained within must be protected and retain customer trust, as well as complying with privacy regulation and mandates that you might have. And the efficiency, care, and integrity with which organizations handle customer data can really improve customer experience and loyalty. And fourth is staying ahead of the competitions. So data fuels innovations and help organizations stay ahead of the curve. Machine learning is one of the most transformative technology we'll encounter in our generations. And whether enhancing customer experience and boosting employee productivity or cutting costs and reducing fraud, machine learning can really help organizations tackle your biggest challenges. A strong data strategy is the first and most important step in every successful machine learning journey. And advanced technologies such as purpose-built databases, analytics, BI or business intelligence, AI, and ML can really help you accelerate innovations and help you realize your strategic goal faster and compete on the basis of data. And last but not least is preparing for the future of the unknown. So data-driven organizations treat data like an organizational asset and not a property of individual departments. And what this means is that this requires data democratizations, which is the idea that everyone in the company has access to the data and is responsible for finding new ways of working using the data. And better alignment around data and access to the right data at the right time enables organizations to prepare for the future or the unknown. And this requires a data-driven culture, which embraces the use of data in decision-making from the top down and investment in the right data infrastructure, solutions, and tools. We talk with hundreds of customers about how they can use data to transform their businesses. In the last few years, we've seen that number increase even faster as organizations of all sizes and industry look to reinvent themselves around data to fuel the insights and predictions that led to better decision-making and innovations. So data-driven organizations treat data like an asset, making it available and accessible to the right team so the teams can put it to work to enable better and more informed decisions. As examples, financial services businesses like Capital One use data to make faster credit and risk decisions. And manufacturing companies like Cisco or Georgia Pacific use their data lake for real-time analytics to optimize predictive maintenance and assembly line clock rates to help them save millions in preventing the downtime of their machinery. And that is the core of enterprise data lakes, which is creating a centralized source of data for the organization that is cost-effective, secure, has elastic scale, and that you can easily provision access so that the teams always have access to the right data. And the benefits of being a data-driven organizations are very, very clear. And so companies that don't embrace this transformation risk are falling behind. Forrester recently stated for a typical Fortune 1000 companies, just a 10% increase in data accessibility would result in more than 65 million additional net income. And they also mentioned that data-driven businesses are growing at an average of more than 30% annually. almost every organization has access to data that they aren't capturing, whether it's rich data about how customers interact with my website or mobile apps, sentiment analysis from customer service call, or metrics about in-person interactions. The first step is identifying data sources that help shine a light on business performance and collecting and storing that data, and then putting it work for you. And then to effectively use that data, an organization must cultivate a data-driven culture, as we previously mentioned, because data alone cannot unlock value. And according to an Accenture report, 55% of companies have a mostly manual approach to discovering data within their enterprise, and only 20% have a strategy in place to take advantage of the analytics tools and infrastructure throughout the enterprise. By building your data lake on S3, you can really improve your data-driven posture to better prepare you and your organization for the future. So now that we've gone through a brief history of big data, data lake, and what led to the data lake architecture today, and what are some of the benefits with a data-driven culture in a data lake. In the next few slides, we'll talk about specifically how S3 can make it easy to run analytics and machine learning jobs over your data. So first, let's talk about analytics on the cloud. Today, there are two prevalent architectures for analytics on the cloud. First is a data warehouse approach, presented here on the left, and also a data lake approach, presented here on the right. So data warehouse approach is where you load and save the data to S3 first, and then from S3, load it to a warehouse services such as AWS Redshift. And from there, you can do everything from transformations, deriving materialized views, doing queries, all from one single place. The data lake approach, on the other hand, is where you not only stage and load the data in S3, but also store, process, transform, query directly against that S3 data using services such as Athena or EMR. And their advantage for each of these approach. The advantage of the data warehouse approach is that it's more managed, where the architecture is more simplified, and you can load your data Redshift and you can do everything from there. But the advantage of the data lake approach on the right is composability. So depending on your need, you can really stack your data lake however you would like. For example, for storage, you can slice and dice the data you have on S3 and leverage the different S3 storage tier to optimize for cost. You can put some into S3 standard, the data that you think are more frequently accessed, and you can put other data into the Glacier storage class for those data that you think will be less frequently accessed. As another example for transformations and deriving materialized views on a data lake, you have a variety of choices. You can use Glue, EMR, or even run your own EC2 or EKS clusters. So the point is, with the data lake approach, you can really plug and play and make the stack however that best suits your needs and your architecture. So for the data lake approach, more and more we're seeing customers implementing what's called a lakehouse architectures, which really highlights the composability nature of the data lakes. And AWS services really work together for you to plug and play to make data lake work for you. And on this slide here, we show you just the variety of options you have for each part of the lakehouse stack. On the bottom, in the ingestion layer, you have the options of data migration service to transfer data from your relational database to S3. You also have Kinesis for more streaming kind of a workload from your websites or your sensor data. And on top of the lakehouse stack, you also have, let's take example, the process layer. You have a variety of choices for EMR for Glue. You can use it for your ETL jobs. Or if you want querying capabilities, you have SageMaker or Athena. So AWS really offer you a lot of choices to help you compose your data lake or your lakehouse however you would like. Besides the AWS services, we also see a budding ecosystem of open source software to make your data lake even stronger. So, for example, for processing and query engines, we had the very popular Presto for writing analytic SQL queries, and also have Spark, which is a very popular library for processing big data today. And for table formats, which are a relatively new kind of ways for customers to store data on S3, we have the Apache Hudi, Apache Iceberg, specifically designed to handle large-scale table. Think, terabytes and even petabyte scale, and high volume streaming ingestions of hundreds of thousands of records per second. And even for file format storing data on S3, we also have Apache Parquet and ORC that are specifically designed on a byte level to optimize for analytic workloads of data on S3. So we really have a lot of choice for you if you choose to go with the data lake and lakehouse approach to compose a data lake for your needs. So with that said, we'll transition to the machine learning aspect of data lakes, and Deb will take it from here.
Thanks, Yui. Hello, everyone. I'm going to talk about how customers run machine learning workloads with S3, and then I'm going to share some recommendations for data lakes on Amazon S3. With its low cost and high durability, Amazon S3 is the ideal place to store terabytes and petabytes of machine learning training data. Additionally, customers benefit from S3's elastic throughput and read terabytes of data at up to terabits per second. And once the training job finishes, customers persist the updated model, again, back in Amazon S3. S3 today seamlessly integrates with Amazon SageMaker. SageMaker is a managed service that makes it easy to build, train, and deploy machine learning models. Depending on the size and requirements of their datasets, customers can use different modes in SageMaker to read the data from Amazon S3. For example, they can use the S3 file mode to download the data ahead of time and make it available for the training job. Alternatively, they can use the S3 fast file mode and access their training files via a POSIX-compliant file system interface as if the files were available on the local disk of their training instance. Overall, Amazon S3 and Amazon SageMaker offer a scalable and convenient solution for customers that need to train their ML models with large datasets at low cost. Next, as I said, I'm going to share some recommendations for data lakes on Amazon S3. These recommendations will help you optimize cost, which is obviously very important, and also help you achieve the optimal performance for your workloads with data lakes on Amazon S3. So let's start with performance. Amazon S3 automatically scales to high request rates. For example, your application can achieve at least 3,500 put or copy or post or delete requests or 5,500 get or head requests per second per partitioned prefix. There are really no limits to the number of prefixes you can have in your bucket, which basically means that you can increase your read or write performance by using parallelization. For example, you can create 10 prefixes in S3 bucket to parallelize reads, and thus you could scale your read performance to 55,000 read requests per second. Now, because transactions per second, or TPS as we call it, is set on a prefix level, getting the prefix structure right can really optimize your performance. Let's take a look at an example. This example uses timestamp as a partition. All the files for a date map to the same prefix. Now, this could be a problem because it will accumulate the request load on that single prefix. One way to address this problem is to add entropy to your prefix design, which basically means distributing your load across different prefixes. More specifically, you can add a random hash, as you can see on the slide, as part of your prefix before your partition name. What this means is that when you suddenly add a lot of objects to a new partition, they'll be distributed across different prefixes with their own TPS limits. This helps you scale better. Amazon S3 is a very large distributed system. To help you take advantage of S3's scale, we encourage you to horizontally scale parallel requests to Amazon S3 service endpoints. In addition to distributing the requests within Amazon S3, this type of scaling approach helps distribute the load over multiple paths through the network. For high throughput transfers, Amazon S3 advises using applications that use multiple connections to get or put data in parallel. For some applications, you can achieve parallel connections by launching multiple requests concurrently in different application threads or in different application instances. The best approach really depends on your application and the structure of the objects that you're accessing. However, as a general rule, when you download large objects within a region from S3 to Amazon EC2 instance, we suggest making concurrent requests for byte ranges of an object at a granularity of 8 to 16 megabytes. Make one concurrent request for each 85 to 90 megabytes per second of desired network throughput, and this would saturate a 10 gigabits per second network interface card or NIC. You might use about 15 concurrent requests over separate connections. You can scale up the concurrent requests over more connections to saturate faster NICs, such as 25 gigabits per second or 100 gigabit per second NICs. Next, we look at cost. There can be two approaches for cost optimization. First, when you know your access pattern or the access pattern on your data in S3, and you want to build your own cost optimization mechanism. And second, when you do not know your access pattern, which is often the case with data lakes, or when you want automatic cost optimization managed by S3. So we have solutions for both approaches, which I'm shortly going to dive into. Because a vast majority of data has unknown or changing access pattern, many customers use S3 intelligent tiering to automatically optimize on cost. S3 intelligent tiering is the only cloud storage class that delivers automatic cost savings for data with changing access patterns, which is, as I said, often the case in S3 data lakes or in data lakes in general. It it provides automatic cost savings without any impact on performance and without any operational overhead. Last year at reinvent, we announced a new access tier that is designed for rarely accessed data that needs millisecond access performance within S3 intelligent tiering. With the introduction of this new archive instance access tier, any object that have not been accessed for 90 consecutive days will automatically move to this new archive instance access tier. This will deliver immediate 68% cost savings for those objects without any impact on performance. As you can imagine, this is the reason customers use S3 intelligent tiering to store shared data sets where the data is aggregated and accessed by different applications, teams, individuals, whether for analytics, machine learning, real-time monitoring, or other data lake use cases. Also, I would want to highlight that S3 intelligent tiering is really the default for many customers today, especially those building data lakes on S3. However, for data with known or predictable access pattern, customers can choose from a set of storage classes that are cost optimized for different access patterns. First, we have S3 Standard, which is the ideal storage class for frequently accessed data. This is the best choice if you access data more than once a month. S3 Standard is also the ideal storage class for small, short-lived objects. Next, S3 Standard IA, and the storage classes that follow on this slide are essentially designed for less frequently accessed workloads, where your cost to store data decreases, but the cost to access your data increases. S3 Standard IA is the ideal storage class for data accessed once a month or twice a month. Next, S3 Glacier Instant Retrieval. It is the ideal storage class for data accessed once a quarter. In addition to these storage classes that offer instant retrieval, S3 also offers Glacier Flexible Retrieval Storage class that delivers additional cost savings with retrievals of minutes to hours. Additionally, bulk retrievals with this storage class are now free. Last but not the least, S3 has Glacier Deep Archive Storage class that offers the lowest cost storage in the cloud and data retrieval in hours. Additionally, S3 also offers storage classes for specialized workloads. For easily recreatable data or for storing secondary copies in a different region, you can use the S3 OneZone IA storage class, which delivers additional cost savings over a standard IA, but stores data in a single AZ. And lastly, S3 on Outpost. S3 on Outpost delivers object storage in your on-premises environment. It offers the familiar S3 APIs and milliseconds access. In addition to these storage classes, S3 offers additional features to help you analyze your storage and save on costs. With Storage Lens, for example, you can understand, analyze, and optimize storage with more than 29 users and activity metrics. It also offers interactive dashboards to aggregate data for your entire organization, your specific accounts, regions, buckets, or prefixes. And all of this data is accessible in the S3 Management Console or also as raw data in your S3 bucket if you want to run analytics on top of that. It also gives you recommendations for cost efficiency and data protection best practices. And last but not the least, it's free to try out. Next, we have S3 Lifecycle. To help you manage your objects so that they are stored cost effectively throughout their existence in Amazon S3, S3 offers lifecycle rules and configurations. You can use lifecycle rules to define actions that you want Amazon S3 to take during an object's lifetime. For example, transitioning objects to another storage class, potentially to save on cost, archiving them, or deleting them after a specified period of time. Putting it all together, let's take a look at how you might store your data in your data lake. This example outlines a very simplified data lake architecture, where raw data flows in S3 and it gets processed by ETL. You can start with storing your raw data in S3 Standard or S3 Intelligent Tiering because it's going to be processed and you need to access it quickly. Then once the data is processed, you want to persist the data in the data lake. At this point, you can use S3 Intelligent Tiering to automatically optimize on cost because you can have multiple users accessing the data in the data lake and the access patterns may not be well known. Finally, when you move the production data to archive, you can leverage a variety of Glacier storage classes to save on storage cost. This concludes the cost optimization section of our talk. To recap our presentation, both what Huey and I shared, we covered a brief history of S3 that explains how data lakes are part of an evolution backed by business needs, and how S3 is the best place for data lakes due to its unmatched durability, availability, and scalability, its best security, compliance, and audit capabilities, automatic cost optimization features like S3 Intelligent Tiering, and integration with a broad portfolio of analytical and machine learning tools like SageMaker. We also shared recommendations on optimizing performance by structuring your prefixes appropriately for scaling. Finally, we shared how you can leverage a variety of storage classes to have a custom cost optimization solution and use S3 Intelligent Tiering if you want an automatic way to optimize your storage cost. Broadly speaking, and as Huey shared before, today the data is transforming every field and every business. It's changing how we think about solving problems, building new businesses, and changing customer experience. Collecting, analyzing, and getting the value out of data will lead to more breakthroughs in healthcare, smart buildings, homes, cities, personalized customer experiences, efficient manufacturing operations, and a more connected society overall. Every business is really a data business, with digital data growing 40% every year, which means where and how you store your data are two of the most important decisions that an organization can make. When opened up across the organization, data can help organizations make better decisions, respond better to the unexpected, enhance the customer experience, uncover new opportunities, and improve efficiency. With better security, lower costs, greater flexibility, and the right tools, you are better positioned to experiment with new approaches and take advantage of opportunities as they emerge. For more information on all of this, visit the Data Lake Storage AWS page linked here. Thank you for joining us during this tech talk. We hope you feel more knowledgeable about the benefits your organization can take advantage of by building your data lake on Amazon S3. With that, we would like to open it up for some question and answers.